Hello, everybody. My name is John Barsadi. I'm with Carestream Dental. Carestream Dental is the parent company of Swiss Meta, so it's just an implant planning solution. So we added this. Carestream Dental, we're known for our CBCT and iOS for scanning. We've now added to that something that you can actually do with it. And the main thing we focused in on was implant planning. So we picked up a software called Swiss Meta, which is a cloud-based image sharing implant planning solution. And Hugo Patrao is both our head of our R&D. He's also our head of training, and he's actually our lead designer in Europe around this product. So we like to utilize him for these lectures because not only does he know how to present very well, but he actually knows not only our software but competing softwares and the reasons behind why we do oral surgery the way we do it. So I'll hand it over to Hugo and let him kind of run through this presentation. Thank you all for joining.
Perfect. Thank you very much, John. So as John mentioned it, I am the head of services and support application training for Swiss Meta. And as you can see here, I am continue to do quite of KOL and testing on printers, on guided systems, particularly working together with the implant systems and the guided kits. So I would be able to give much more feedback and customize the software according to the needs and keep evolving with implants companies, because this is not a static science, and we really need and want to move forward with our cases. Okay, so what we can see there is our own agenda, and what we want to deliver to everyone is firstly, we want to maximize the chair time for everyone. Obviously, we don't look to do guided surgery only as a gimmick, but we need to get something out of it, right? So we really want to make it for the patient as easy as possible, because patient recommendation is probably the foremost important type of marketing. Second, what we're going to discuss here is how to achieve accuracy with guided surgery, at the same time increase the profitability. Obviously, everyone needs to get profitable because we are not working for charity. And if we want to keep up with all these technologies, we need to make sure that they are profitable so we can continue to evolve as with the company as well. And the third, obviously, we're going to discuss about immediate approach to implant placement, which is quite important for us, simply because patients became more and more literated, and more often patients come and say, you know what, doctor, I would like to have these tooth replaced today. Don't even think that you're going to extract one tooth, leave me 1 week without any replacement, and I would come back afterwards just to get my final restoration. Can we do it? Can we actually place an implant where we did extraction? Can we actually replace on the same day? Can we do all in the box teeth treatments with guided surgery? And hopefully this is what we're gonna end up. So our main objective as clinicians, technicians, support teams is to achieve patient experience, safety, accuracy, predictability, profitability, and simplicity. The only way that we can actually say that guided surgery is fully accomplished a good way on our world is when we actually achieve all these 6 lines of reasoning. And none of them is more important or less important on when we're doing the plan, because there is no point to have a very complicated surgery, a very expensive surgery, if the patient is not going to get a good experience. Could be the safety ones, but if the patient doesn't have a good experience, reduced time, patient will not like it. Okay, so let's start with misconceptions, with a lot of discussions that I have been around and been asked. Are those old-fashioned guides, the one that we see, the analog 2D, true guides, true digital guides that we be able to use and get an accurate implant placement? The answer is very simple. No, they cannot. They are not implant guides. Okay, we cannot call them that. The true name of those is prosthetic guides. So basically, those guides only tells you where the technician would like to place a crown and where your abutment needs to come out. Okay, so it doesn't take in consideration type of bone or the osteotomy or depression or defects or even a funny root next to the implants. It's just an idea where the abutment needs to come out. So to make it clear to everyone, those are not digital guides. Those are not implant guides. Those are temporary or restoration guides. So today, for the sake of accuracy and clarity, we will discuss about full 3D guides. Guides that involve that you need to have a DICOM file, you need to have an intraoral scan from the patient, merge it everything together, you plan an implant on a piece of a software, and out of that, you need to print, or the worst case scenario, mill the guides to guide your surgery. Okay, so it's a process involved, and everything that we're going to discuss today is on those types of guides. So evolution begins of implant planning. At the beginning, this is how people will be able to do it. They will take a 2D image and they will draw all the adjacent elements, tooth, nerves, gingival margins, and you might have opaque, radio opaque stent to tell you or let you know what is the ideal scenario or the ideal position for your implant. So for example, this one now, we just need to pick one implant for the correct size that not hit neighboring teeth and also doesn't hit the nerve. And with the limitation that we had before, that could be one of the best ways to plan it. At least you have some kind of a planning. Although with the time going by, we realize that this is not true. Okay, so this is a typical example where we might look at this panoramic and you say, okay, so if those are tissue leveled implants and I look at the bone and the bone doesn't look too bad, looks like that my implants are too deep. Okay, and this is actually how people used to plan it. Well, they are too deep. Shall I put it out? Shall I put it in? What can I do with it? They are away from the nerve, or just leave it as it is. And you know what? Those ones would actually have a problem, because if they are too deep into the bone, then the bone would start to resorb. But let's see, are they really too deep? When you start to looking at 3D images instead of 2D images, you realize that in one aspect, buccal or lingual part are really too deep. Yes, it's true. But on another aspect, they are exposed. So that will be a recipe in the start of a hell of a journey, because if in one side you're going to lose the bone, on another one you will also lose it because the threads are exposed. Threads exposed push and encourage the bone to decrease, and then the gingiva would come together with that, and you start to having the chances of implantitis increased over there. Okay, so this is the typical scenario that you never want to encounter. In one part too deep, in another part threads exposed. So the only way to prevent that is by having CBCTs, by having a good software in the guide that actually guides you to put an implant in the correct position. Obviously, in situations like that, you would need to manipulate the bone. You would have to do a surgery slightly more complicated, but they don't become complicated because you know all the issues that happen. You are prepared for that. And this is exactly what we're talking about today, is the issues, they will happen, but you are prepared for any kind of issues or problems that may arise during the surgery. So this is exactly what we're talking about, is with guided surgery, we move from what is well known in Europe as a reactive surgery to a more predictable in control surgery, because you don't need to react along the surgery. Okay, so what we can do here? Well, when we look at the surgery, guided surgery, we look for accuracy versus precision. And when I keep asking some surgeons what is more important, accuracy or precision, some people actually became, well, I thought that is almost the same thing. Accuracy and precision could be the same thing, but it's not. In surgery, in guided surgery, it's important to understand the difference between them, accuracy versus precision. So our goal is to achieve both of them. If the accuracy is the true to the intention, the precision is the true to himself. So what we want to do is become accurate and precise, because someone can be very precise to make the things off or wrong all the time. So you are really precise to the intention, and not to itself and not an intention. So how can we do it with the dental market, with the dental procedures? And why on the dental procedures becomes more difficult? Because when we place the implants, not always we don't see it from the bird's eye view, where it's easier to place an implant and easy to control the horizontal, vertical angulation of the implant. But as long as you go in distal of the mouth, premolars, molars, all the way back, you lose all this bird's eye view. And sometimes you need to aid yourself with a reflection mirror. And that will actually make the accuracy be the precision be more difficult to achieve. How can we achieve it? With a guided surgery. If that's what I said is something as a common sense, a common agreement, you might be asking yourself, yeah, I understand that. And if the guided surgery deliver this kind of accuracy and precision, why is not more popular? If the guided surgery aims is to get an implant no more than 0.1 millimeter deviation bodily and no more than 5 degrees angled wrong, let's say, or deviated from the planning, that's actually a really good tool. But the true fact is not all the softwares, not all the techniques are as precise. And the study that you can see now shows clear that the results from some guys was almost 1 millimeter bodily moved and almost, or some of them, over 25 degrees angulated. So if I ask any one of you, would you buy a guide for 200, 300, 500, $1,000 guide that eventually have a chance to have an implant 1 millimeter moved bodily in 25 degrees angulated? The chance that you say, I would never risk it because I prefer to get less accurate or less predictable, but at least I know what I'm doing. Okay. And this is the reason why guided surgery is not more popular at nowadays, because old systems, they were not predictable or not accurate as they are now. So one thing that I would say today is, if you even look for guided surgery, make sure that you select one system that delivers a 0.1 bodily movement and no more than 5 degrees angulation, and look at the studies and take your own conclusions about that. One thing that is I like to show is the following video, where actually I asked the same doctor to take a photo, a screenshot of the planning, and then the PA done after the implant placed. And as you can see, some of them have micro deviations, true fact, but the majority, they are really accurate. They are close to the sinus. They are close to the neighboring teeth. They are on some very narrow spaces, difficult spaces like this one, but the implants end up exactly where we planned it. So there was no surprises. And obviously, I'm not going to run the full video right now because it's 50 cases. But as you can see, guided surgery can deliver to you that level of accuracy and predictability. So means, and we're going to touch that you can have your restoration done before the surgery. So no more placing an implant, healing abutment on top of that, and ask the patient to come back in 3 weeks or 5 weeks or 6 weeks, whatever it is, to have the crown placed. In some of the cases, and maybe the majority of single cases, you will be able to load it directly with a pre-made crown, which is much simple and easy to plan. So what we need to make sure, okay, and where all these errors that we discussed before, they came in. Well, they come from sometimes the software is not good, but sometimes the type of data that we feed the software with is not ideal. So one thing that is important, and obviously we're not going to dissecate this information right now, we're probably going to invite you to other events, but make sure that your CBCT is nicely taken. It's not something to be rushed. Your intraoral scan needs to be also of a nice quality, because if you don't have good data from the beginning, you cannot expect to get a good guide, accurate procedure, and accurate outcome just because the original data was not correct, okay? So some of the tips that we might share with you at different webinars is using cotton rolls, keeping jaws separating, remove metal from the patient's mouth Don't use any radio pack temporaries. Is important. Why? Well, is another subject that we can touch it, and hopefully you'll be able to join on a future events or webinars. So moving forward for another part of the guided surgery, one thing that I would like to demystify here is guided surgery is not simpler than freehand guides, okay? Why I'm saying that? Because as you can see on these slides, the normal guide, if you have an implant that is 8 millimeters, you get 8 millimeter drill and you drill it. So there is nothing more simple than that. And when you have a guided surgery kit, yes, you have metal sleeves, you have longer drills, you have much more components involved, you have keys. But you know what? That is not difficult to learn it. You might need to have a little bit of learning curve, but as soon as you become familiar with that, then is a walk in the park because it's automatically come to you. But take your time if you do guided surgery to learn about guided kits. This is just a typical example that you have it here. I would compare it as driving with a GPS. If you don't know how to drive, or if you are really new or how to drive, if someone's put to you a GPS and ask you to follow that orders, might be difficult for you to get it. But as soon as you learn how to drive and you learn the informations that GPS is feeding your brains with, then your ride on your car is much more pleasant. And this is exactly what we can assure you that guided surgery deliver to you. As soon as you allow time for a learning curve, your joy on doing guided surgery increase with the time. And the accuracy is going to be a really nice present at the end of every single surgery that you do. So the takeout from this slide is take your time to learn guided surgery, not the guide himself, but the drills, the keys, the sleeves. Pick a good one, and then you will enjoy a good guided surgery. Now, let's discuss another part as well on guided surgery, because as you can see, a lot of people think that guided surgery is very simple to do it, and it's just a bit of plastic there, and whatever we plan it, you have some holes and just put some drills or screws through the holes. It's not the case. We learned that to get a good guide, good accurate guide, you need to have good piece of data, you need to have a good guided kit, drills and components, but also the type of the guide is quite important. A skeletal guide, spaghetti guide, scaffold guide, you call it whatever you like it. But why that guide is important? For some of you, you might think, I never saw a guide like that. This is quite new. Yes, it's true. We have a patent on the design. And the reason why we create that patent and we really advocate this type of design, because as you can see on the pictures on the side, a guide like that gives you a full visibility of the operation site, a better control of the feet, easy cooling. The only way that you can cool a surgery site is through saline, water, and air. So if you shell the surgery site, the osteotomy site, with a bit of plastic like a mouth guard, you don't get any water or any air to ventilate it, and the chances of necrosity increase within the time. So as I mentioned to you, is easy to raise a flap as well. There is a misconception that guided surgery is flapless technology or a limitation of the surgery, and it's not the case. Any guide that limits your surgery, in fact, what it does is not a good guide. As you can see here, a guide can be flapless. You can open the flap before. You should be able to open the flap on any time of the surgery. So you need to have easier access, and this is the reason why we urge you to try a skeletal guide design compared with any other one, because again, the outcomes would be much nicer. So we discussed already type of data, type of surgical guided kit from the implants, and the type of guides. So a skeletal one. Now we're going to discuss another misconception as well, if guided surgery should be full guided or should be only the pilot. Okay, so let's not only discuss those two for now. So pilot guide is, as everyone knows, up to 2 millimeter or 2.2 millimeter first initial drill, which is true. It gives you a lot of freedom. It's simple. It's only one drill through the sleeve, fits all the cases because you can do is very flexible, right? So as soon as you have the drill, then what you do, you have the depth and you have the angulation. of your osteotomy control, and then you just use the drills to drill it. So on an ideal scenario, this is what would happen with the pilot surgery. You just go with your pilot, you have a 2 mm osteotomy, then the second drill goes in and you make the osteotomy slightly wider. The third drill or fourth drill would go even wider, and then the implant should go exactly on the axis of the pilot drill. And that would be the nice scenario. Although, as you can see on these slides, why I'm saying that pilot drill is not accurate, is not predictable. Well, because in true fact is with the bone is not with the same density all the time. So when you drill your first drill, it's true that it's guided, so exactly as you plan it. But as soon as you start to adding other drills, the drill start to shift where the bone is softer. And then you go a little bit wider, and this is happen again. And one fact is none of the threads of the implant likes to create threads where the bone is dense, like cortical bone. So what you would be able to see is the implant will create the threads always towards the softer bone. And on this scenario, I actually only create a simulator of moving the implants bodily. But because you have notch of harder and softer bone in voids, actually the implant can be moved bodily and angulated out. And now when you look at this, if you start with the drilling pilot of 2 mm and placing a 4 mm implant, the axis of your implant can actually be 1 mm off. And this is what explains all the difference that we saw a couple of slides ago. Okay, so when you have the implant 1 mm bodily moved and up to 25 degrees angulated out of the planning. Okay, so this is exactly what I'm talking about. Pilot drills are good for some things, yes, but be aware that they are not predictable as a full guided. So a full guided fitted over the teeth or over the gums, where you can actually use the pallet and use some pins or screws to do your planning, actually work on a slightly different way. So because we have the sleeves holding always the drill into the correct position, the chances that all the osteotomy is follow exactly the planning is increased substantially. But important to mention, please pick a guide that also allows you to place the implant through the guide, because again, all the threads will force the implant to go sideways or angulate it wrong, and you don't want to do that. Okay, now looks like that everything is perfect on full guided surgery. Why did I put it that fits all in yellow? If you have a knife edge bone or a very narrow bone, well, you might not be able to drill 4 mm or 3.5 mm. So you need to do split ridge, or you need to do other different of techniques. But for most or majority of the case that you don't need to do that technique, you be able to use a guide, and definitely the outcome is going to be more into the line. Why is not simple? Because as we mentioned before, we have much more components to the guided kit, but as soon as you get the hang of it, you will not have any issues whatsoever. So again, the takeout from pilots in drilling guides, full guided, is yes, pilot is good for a certain sense, but it's not going to be as accurate as a full guided. Just to prove exactly what I mentioned here is now we have a grass. And as you can see here, we have three colors, the green, blue, wherever you see it on your screen, is freehand final drilling, compared with the freehand placement, compared with the full guided. We are not talking about freehand placements, okay? The final drilling means that the first and the second drill were done through the guide, and the third drill was freehand and the implant placement freehands. This is the blue-green one. Then the yellow is all the drills were done through the guides, and only the implant was not played through the guides. And then you have the full guided that includes the implant through the guide. And as you can see and testify it here, you'll be able to see that the discrepancy between the final placement in regard to bodily moved and angulation decrease substantial as you go more guided and more guided. And if you note on those dots, some of them, they are really off, okay? So what I want to explain here is if you do more steps through the guide, more predictable is going to be your case. So another reason, and we discussed until now, why we should go for guided surgery: to get accuracy, to get predictability, to get all these nice things that would like to come out from a surgery. But the more important for me is as well to avoid bad errors or accidents, okay? Why those accidents happen? Well, simply because we cannot control the shape of the bone that the patient has. And if it's true that we would love to have C-type bone, wide, meaty bones to be able to place the implant, cases like that is only 14%. In parallel bone is only 20%. So leave us to 66% of the cases, actually the U-type bone, especially on the posterior, we have where you have a massive defect onto the lingual undercut. And unfortunately, 1.7% in average of all the cases placed, that you end up with a plate-to-plate perforation, okay? And I can assure you that some very experienced doctors end up on that situation that they need to refer patients to A&E, okay? And I'm sure that no one's want to have that, but because they were misled by bad data, bad planning, bad drills, whatever it is, you end up on that situation. So this is exactly how guided surgery can help you to prevent and to be able to visualize it beforehand such complication. So let's take this bone as example. A lot of surgeons, they say to me, you know what, single places on the premolars, it's very simple to get it. I just go and squish, the gums, and I see how much bone I do have there. Or I take the panorama and I see if I have enough bone, then I get it done, okay? So for me, is very important to see this case. This looks like a straightforward case because we have lots of bone height. We have 12 millimeters, so you can use any implant on a catalog and will not have any issue whatsoever. And if you are not sure about the width of the bone, you go just for the 3.3 and protect that crown and you're going to be fine. But look at this massive surprise that we have here. Yes, you have 12 millimeters of bone, but below the 10 millimeters, you start to having an hourglass bone shape. So definitely you don't want to drill more than 8 millimeters of implants because you're going to end up with a lingual plate perforation. So we move from a very simple surgery for a surgery that limiting you the size of the implants. And if you only have 8 millimeters of implant, you might not go for a 2.2 millimeter implant wide. You might need to go slightly wider to get volume engaging with the bone. Okay, so this is the beautiful of planning the case beforehand with guided surgery and knowing that even on nice tight spaces, you will end up with a nice predictable results. Another thing that we want to avoid is aesthetics errors. Okay, what I mean by that, if you look at this case, and if you have not been on the 3D course, implant course before, you might look at this implant and say, yep, straightforward. Premolar there, plenty of space, a lot of bone, nice healthy bone. Even the crest of the bone is flat, so leave it the implant as it is, and it would be osseointegrated perfectly. And you are right. That implant is perfectly placed inside of the bone. Although we need to start to planning the implants not only according to bone, but also according to the aesthetics. And this is where interdisciplinary reaction in planning comes into play. Because a lot of cases that you have that implantologist place an implant, and then you end up with a hot potato of trying to restore that implant, and for some reason you cannot, simply because the implant was not planned on a PDIP position. What I mean by PDIP? I mean prosthetic-driven implant placement. So where is the crown? Where is my gingiva margins? Where is the zenith of my case? And look at this small detail. Although this implant looks perfectly placed, if the zenith of the crown is over there, how we will be able now to manage the emerge profile? We don't have enough space for all the components, abutments, and everything else. So what you will end up with a situation like that is with a tomato on a stick. And I can assure you that cases not probably done by yourselves, you saw a lot of posteriors where the crown is so shallow and difficult to clean, foot pockets underneath there, and you ask for why this is happened. Well, simply, you have two now, once those implant is placed so shallow, you have a limitation of space for your crown. You cannot go higher than occlusion, and you cannot go below the prosthetic elements, abutments, and so on. So you end up making a crown that is very shallow and doesn't look good. So instead of you end up with a nice implant subcrestal placed, gives you enough of emerged profile so you can design a nice crown, you end up with a situation like those. And I'm for sure that you saw it, a lot of those on your surgeries. So following a study that shows that all the implants, they should be on around 3x3, means 3 millimeters crestal and 3 millimeter labial or buccal plate placed to be able to get a nice and controlled emerge profile. This is the same case now applying a true rules. So instead of we using a 4.313 implants, we should use a 3.8. So we have the zenith over there, then we have 3 millimeters going crestal, 3 millimeters going palatal, and then our implant needs to be placed much deeper. But this way, I assure you that your crown will fit perfect over there. Now you're probably looking at that, but it's too much bone there. Yes, you need to do some bone contouring over there. But again, this is exactly the beautiful of guided surgery. You know that you need to do this bone contouring, but you know it beforehand. So you can even talk with the patient. You can even prepare instead of end up with a surprise, and you need to fast going there and try to compensate it for all these kind of surprises during the surgery. That is impossible to plan if you just plan it on a PA, or if you don't know where your crowns you're going to enter. So today, the lecture or the webinar is not only about guided surgery, but planning things PDIP, prosthetic-driven implant placement with guided surgery, with predictability and accuracy, end up on a nice situation where you can deliver the implant straight away out of the box. So that is exactly what we discussed. With the digital planning, we understand exactly what to do with no surprises and improve patient experience and outcomes. Okay, so let's see a case. Let's just see one case from Dr. Biaz from Lucerne. And this case needs to have this central replaced. But when we plan this case, we know that there is no bone. There is a massive bone defect. How are we going to plan these implants? For some of you that looking at this one may think, oh, that implant is completely off the bone. But it's not. It's actually the only position that we can actually do it to not end up with the access screws, too much buccal or too much palatal or whatever it is. That should be the ideal scenario. Although if you try to imagine drilling freehand, your drill will skid always out of the bone and you will never end up creating the threads where you should go. But let's see how the surgery will end up. So the doctor used the guide to drill it through, so he got the drills exactly not skidding out of the bone. And once he actually placed the implant through the guide, he ended up with the implant exactly where we planned it. So now he can bone graft it, membrane it on top, then do the suture, and that was the beautiful result. We don't have a resorption of the papilla. We don't have a very high cervical level. We don't have any funny shape of the crown because the implant was correct. When you use a guided kit from the implant company, actually what it changed is the components that goes inside of the sleeve of the guides. So you don't need to remove the guide, put another guide and remove it, make it more complicated. You just need to replace the components that goes through the guide, and the implant becomes, even as you see now, this is the implant placed through the guides with a specific carrier, but the guide never leaves the patient's mouth. Cool. Just want to clarify that slide. A lot of people saying, guided surgery increase the costs. And again, that is another big elephant in the room. Because it doesn't, okay? By increasing the efficiency of your surgery, compared with the analog type approach, you bring your costs down. We are not talking about costs of the guide. Obviously, the guide needs to be paid for. But from the moment of assessing the consultation all the way to the design of the final restoration, we estimated together with a lot of surgeons on 1 to 2 implants, average surgery time reduce 3 hours. Okay, so if you do your maths now, how much is 3 hours of share time? A lot of money. So pays for the guide, gets you more accurate on what you're doing, more predictable, and also assuring you, if you ask a patient if he prefers to spend 4 hours into a share, being assessed in implant placement surgeries, or 1.5 in 1.2 hours in average for all the treatment, I know that you know the answer of that. And that patient would go out of your door and say, you know what, if you want the implant, please go to that doctor because that was an amazing experience. So now let's put some hands-on this one. Obviously, I cannot ask you to do it, but just to make sure that everyone understands how easy it is for everyone to ask for a guide or to go through that level of surgery. So we don't ask you to understand softwares inside out, spending hours on webinars or spending a lot of time learning the softwares. I don't think this is exactly what it should be. You end up spending not time on surgery, but on your computer. So this is not what we want to do. We want things easier for you. So there is a couple of steps that we ask for all the surgeons, and then things became much easier. So the first step is acquired good data. Good CBCT, good intraoral scan. Then you just need, as a doctor, need to share or upload that information into a portal, into a cloud solution. Takes no more than 5 minutes, and I will show you how to do it. Then what is happen, you don't need to do much because a partner will prepare everything for you. Will do the famous matching of the CBCT together with your model, design your crown, prepared everything for yourself. Once they finished, there is no more screen sharing or team viewer time. There is no need for that, spending or killing time from your surgery. They will send you an email and you just need to add, remove, adjust an implant position. So the planning is still on the doctor's hands and you will see it how easy it is. You just approve or reject the planning and ask for the guide afterwards. So before going on the questions, this is exactly what we're talking about. Once you have the CBCT, you go to the specific portal using your username and password. You don't need a specific software for that, and upload the data. Once you upload the data, you get an email confirming the order of exactly what you asked. And then you have an email asking to inspect and to approve. Okay, so it's simple as it is. And before we going on a hands-on, so you'll be able to see how easy it is to do it. Perfect. So as I mentioned to you, how you would upload a case. First step, right? Very simple. You go to the website that we will have it there. You put your credentials. Obviously, it's going to be your email, your password, and you log in. Once you log in, you press on upload a new case. You upload a new case. You put the patient name, what jaw you want, upper or lower jaw, let's say 24 position for my implants. I would like to do a Straumann implant. Oh, sorry, patient 999. And here I'm going to do a Straumann implant. And here, for example, a BLX implant. And here is going to be a Velo kit. That is simple, is self-explanatory. Press next. In here, you just need to tell us how you would like to design the guys with a flap. Yes, minimal flap or bone augmentation, fixation the guide with what screws, all simple questions as a normal prescription. Press next and you should add the files of your CBCT. So you go through, look for the files that you have it there, load all the files. I'm not going to do it for the sake of speed, but look for all the files that you have there for the DICOM file and the intraoral scan model that you have there. Okay, so the one that you just scanned from the patient's mouth. So we're going to do these two over there. Once you press open, all the data is there. You can the posing or WhatsApp that you propose, any pictures if you desire to. They are not specific or they are not mandatory. And then you put any extra recommendation that you would like to have on your guide, press next and select what type of the guide you would like to have. Once you do all of that, okay, you just need to select what kind of address you prefer to do. Because if you have more than one clinic, you might want to have the guide send it to a different clinic. You just agree with everything here that the guide is going to propose. You just be able to review all the treatment plan that you did, and definitely not going to cost you €2, but this is just a demo case. But you place an order through that and you confirm. And this is exactly what it is. It's just 2 minutes to upload your case. And now you can go and rest because someone at the lab will do everything for yourself. So as I mentioned before, the case that you're going to have, and this is what the kind of email that you're going to get. Let me just show you again. This one. So we upload the case. Once you upload the case, you'll get an email saying that you will get this order done and shipped to the lab. So now you just need to rest and wait for the doctor, okay, that will tell you, look for the case 44430. For example, this is the one that we just created, 44430, and please approve the implant position. And that's all, okay? And let's do that. So we go to, now we're not going to go to the web. Soon we're going to have the web. But if you have the SMOP installed on your machine, you do exactly the same. Now that you receive the case 444, then you need just to log in as the same credentials that you did online, log in onto your software and search for the case number 444430 and hit search. Oh, sorry, one for more, like that. And there it is, your case. And look what the software tells you. Implant planning ready for approval, because this is exactly what your lab asks. Doctor, do you mind to open the case and approve the case? And what will happen is the case will open and you can start reviewing cases 2 o'clock in the morning, 1 o'clock, 5 o'clock, 3 o'clock. You don't need to wait for the lab to screen share the case with you. And when you see the case over here, now you see that exactly what you planned, like that, your model is there with a Straumann bone level X with a T-sleeve. And look what the lab did for you as well. They create a wax up. So now you'll be able to see and to measure the zenith of the case. So even if the lab creates a little bit of mistake, as I have it here, see the same case that we have before, you can go and adjust your case. Let's measure 3 millimeters up, like we discussed it before, 3 millimeters to the sides, like that. Perfect. Now everything is as it should be. And now I move my implants into here. So let me just select that implant position. I move my implant to here. And now I do have my implant 3 millimeter by 3 millimeter. I can go wider, just grab the ball and just to go wider, check if you have enough bone. Actually, you can do a 4 millimeter or a 4 or a 3.75. You want to make a shorter. Definitely you can do, just drop that ball at the apex of the implants. And now look what we did. Although the lab offering you a 375, you actually say, you know what? I would love to have a 4.5 by 10. And now I'm very happy with that. And the software even give you another option. Instead of you spending a lot of time measuring, you have a halo around the implant of 1.5 millimeter that you can change. So when you surf through the implants, you'll be able to see. So for example, okay, this is the canine root finished. Now the safety cylinder goes through and now I have my implants and yeah, looking through, I don't hit any other implants. I don't hit any other problems. I'm very happy with that implant position. How do you communicate back to the lab? You just go here on the top, press export, you approve the position, go on a shopping cart as you do normally, and I confirm the order's conditions because I like it and I approve it, or if you need any corrections, you can do. But once you approve the case, then this is what is going to happen. The lab would design the guide for you, ship it to the right address, as you can see here, and you literally spend 5-10 minutes uploading the case, planning the case with a certainty that you're going to end up with a nice result onto your surgery. Okay, so this is exactly what we discuss. So I am more than happy to answer any questions. Hopefully you like what we presented. I try to make it very simple, so lively for everyone. So leave word for you guys.
Yeah, thank you, Hugo. That was fabulous. I'd like to mention that Spectrum Toronto in October the 20th, I believe Hugo will be there doing a one-hour lecture at that meeting. Again, I'd like to thank John for being here and taking care of this also. And then we have another John who's the event host that's been putting everything together also. So I appreciate everything. And Hugo, we have a few questions, but what we're going to do is not just answer them now. I'll send you those questions and then I'll get you can answer them if you don't mind. That'd be great.
Sure.
Okay, so thank you, everybody. All the best, everybody, and take care. Bye now.
Thank you very much.
Thank you. Bye-bye.